So we are going to start with the new chapter today, which is sound. Now, and in this class of today, we will learn what is sound. So you will all understand what is actually sound, how is the sound produced, what are the various sources of sound. Sources means from which all places does the sound come from, what type of sounds are there, and what are the mediums of sound. Mediums means, can sound travel in air, can sound travel in solid, can sound travel in liquid. So these are the various mediums of sound. First, I want to know from you, what do you know about sound? Anything that you know about sound?
Ma'am, sound is made from vibrations.
Very good. Sound is vibration. Okay.
Sound travels in air. Sound travels in air.
Sound travels in air. Fine. How do you know that sound travels in air? Yeah, that's why you all know that.
It travels in an audible mechanical wave.
Okay, very good. It's an because it is sound, it is audible, it is mechanical wave. Yes, please. Yeah. Yes.
Sound is a form of energy that can be heard and travels in waves.
Very good. Sound is a type of energy which travels in form of wave. So if you know that sound is a wave, you almost know half of it that I'm going to teach you today. Yeah. Okay. So shall we move ahead? So sound, as most of you said, is some kind of vibration, is some kind of wave. How do you know what is a vibration? Vibration, you see this picture here? You see these waves here? So these are waves, these are oscillations, these are vibrations. Suppose you take spoon and start banging on a plate. What is going to happen is you will hear the sound, but you can also feel vibrations. Have you ever felt that there is a very loud sound, like some crackers bursting outside or some aircraft flying very close above your houses? Even your windows also start shaking. So those are nothing but vibrations. But what you hear is the sound. So sound travels in the form of vibrations. Okay. So sound is nothing but vibration. It is a to and fro motion, which is called a vibration. To and fro means forward and backward motion. So any forward and backward motion is nothing but vibration. For example, you see here, how is this wave going? Wave is going up, forward, down, backward. Up, forward, down, backward. Again up and down. Up and down. Similarly, if you see this vibration also, it's going up and down. Means it's going in the positive direction, coming back in the negative. Positive, negative. So this is called to and fro motion. So if you make any to and fro motion, it becomes a vibration. Is this very clear to all of you? What is vibration? Vibration means any to and fro motion. Any forward and backward motion is called vibration. Sound also travels in the form of waves or oscillations or vibrations. Okay. Now let's say veena, you have sitar, you have guitar. So even in these instruments, in these musical instruments, you can feel vibrations, isn't it? What is that part in this veena which vibrates? That absolutely strings. So in veena, when you take each and every string and you try to move it, it vibrates. Even similarly, suppose you take a rubber band and stretch it, and then from the middle somewhere here, take these two strings and try to give a small jerk. You will again hear some mild sound, isn't it? It will not be very hard, but it will be very, very mild sound. So that sound is because of vibrations. Those vibrations are very feeble, not very heavy vibrations, but because of these vibrations, you will hear the sound. So sound occurs because of vibrations. Wherever there are vibrations, you will hear sound. Okay, you're speaking. You're talking to each other. When you speak, there are vibrations. That's why, suppose we are all 40 of us are sitting in a class and the last boy or the girl is speaking, even I'll be able to hear that sound because sound travels everywhere. Okay, so When you speak, there are these vibrations which are coming out from your mouth. When I speak, these small vibrations are coming out from my mouth and they are reaching your ears. That's how when you speak, I'll be able to hear them. The school bell, it rings. Those are vibrations again. When any musical instrument is being played, that is a vibration. When you're listening to music, actually what are you listening? You are hearing, you are listening, you are receiving vibrations. So even this pendulum is vibrating. I told you what is vibration. Vibration means forward, backward, forward, backward. Okay, so look at this. The pendulum goes forward, backward, forward, backward, forward, backward. Isn't it? So this is also a kind of vibration. Look at this. Go up, down, up, down, up, down. Vibration again. Now let us see various instruments which produces sound, and also let us learn what are the parts of those instruments which are actually vibrating and producing the sound. So you see this musical instrument which is called ektara. Okay. So tell me which is the part which is vibrating here?
String, which is the kind of string.
Yeah, this black color string that you see here, this black color string, that is the string which is vibrating. Okay, here this boy is banging this vessel with the wooden stick or something, or let's say spoon. So which part is now vibrating here?
Utensil and the vessel.
Yeah, base of the any pan or whatever utensil he is holding, that is vibrating. Look at this. Veena, you all know strings. What about tabla? Which part of the tabla vibrates? The upper portion. Okay, so this upper part is called as membrane. So in tabla, what is the part which vibrates? Membrane. So in the flute, you have these holes. Okay, so what is that thing which was vibrating here? The air passes through these holes. It is the air column which vibrates in the flute. Okay, what do? You close few openings and you open few others. Okay, so because of the variation in the opening and closing of these openings, these holes, you are able to produce various different sounds, isn't it? So it is the air column which vibrates here. What about harmonium? What is vibrating here is again air column. Again air column, because it is the air which is actually making all the difference here. Okay, so it is the air column. Now look at this. There are 5 glasses and each glasses have been filled with different amount of quantity of water. In the first one, the water is up to only this level. Second one, the water is little more. Third one, half, more than half, and this is full. So if you take a stick and start tapping on these glass, you will get different levels and different pitch and different quality of sound. Okay, this is called as jaltarang. Which is the part which is vibrating here? It is again the air column. How? Look at this. In the first glass, what is the amount of the air which is vibrating? This air is vibrating. This much. More air is vibrating. Here, only this much air is vibrating from this level to the top. Here, this air column is vibrating. Here, only this is vibrating. And in the glass, very thin layer of the air column is vibrating. So there is a difference in the column of the air. Okay, the length of the column in each of these glasses, the length of the air column is different. So if the air column is different, then it will produce different types of sound. So in jaltarang, it is the air column which is vibrating. I'm sure you must have tried all these tricks. Okay, you can take 2 pieces of paper like this, thin strips of paper, and hold them together and try to blow the air in between. Be a little gap between the 2 strips, at least from the...
And they produce sound.
Yes, they produce some sound. From the 2 sides, from here and here, you're holding the strip with your hands. Only from the center, you have to have some gap between the 2 strips. So when the air comes out quickly in between the 2 strips of the air, the two strips will start vibrating and they will produce sound. Whenever there is vibration, there is some sound produced. Okay, so this is the kind of table that you have to make in your notebooks. What you have to do is write all the musical instruments and write the vibrating part in front of it. So this is the table that you have to draw. Let's talk about the sources of sound. What type of sounds are there? What are the sources from which you get sounds? Say you hear the music, so there is musical instruments or musical sound. Okay, then you get sound from homes. Somebody is cleaning the house, somebody is washing the utensils. So all those sounds are called as domestic sounds, which you get from houses, from the domestic areas. So these sounds are called as domestic sounds. Even musical instruments also can be a domestic sound, because people hear the music, at homes also. What are industrial sounds? Very easy to comprehend. Industrial sounds are the sounds which you get from industries, factories, isn't it? So these are the sounds which you get from factories or industries. Traffic sounds are also there. I think this is the most which creates sound pollution, traffic. Okay. Now how do you produce sound? Where does your sound comes from? Your sound comes from voice box. Okay? Try and hold your voice box like this as he is holding. Okay? So what will happen? If you try to speak something, your sound will change. Normally when you try to speak, your voice will be normal. But if you try and hold your voice box, then your sound will change. Okay, hold it tight, again your sound will change. Now how do you produce sound? Look at this. This is your voice box. Inside your voice box you have these two cords. Okay, this is called lyrics. This is called voice box, also called as lyrics. Okay, and inside the lyrics you have these two cords. These two cords are like the two strips of paper. Have you seen in the previous slide those strips of paper? So these two cords are also like two strips of paper. These are very close to each other. Now try and speak something. Suppose if you say force. When you say this word force, what happens is you are trying to get air from within the lungs and you are blowing the air out from your mouth. So what is happening is this air comes out quickly from in between these two cords. Okay, when the air comes out from these two cords will start vibrating, just like those two strips of paper vibrated. Just like that, even these two cords will start vibrating, and when they vibrate, that means there will be sound produced. When you whistle, then the air comes in between your lips, the two lips. See, you can't whistle if you hold your lips apart from each other. Only when you bring these two lips, hold them tight against each other and just leave a small space in between your lips, then only you are able to whistle. Otherwise, if you hold the two lips closed, tight against each other, again, no whistling. If you hold them apart, no whistling. But only if you hold them close to each other and only allow a small opening in between your lips, then only you will be able to produce some whistling sound. Now, next is the beauty of the sound is that it can travel in gases, liquids and solids, all three mediums. What do you think? Where do you think is the speed of the sound maximum? In which medium will it travel faster? Okay, fine. Most of you, I hear gases. One or two had said solid. So let's see what happens. Now what you do is, see, this is the graph. It travels fastest in solids, a little slower in liquids, and very slow in gases. Why do we feel that the sound travels fastest in gases? Is because you feel that when ma'am is speaking, we are all able to hear the sound as she speaks. Simultaneously we are able to hear the sound. At the same time, when she's speaking, we are all able to hear the sound. So you feel that the sound travels fastest in gases, but it is not so. I'll tell you what is the reason. Now look at this. The molecules in the solids are compactly packed. They are packed like this, very very close to each other. In liquids, what happens is they are slightly apart from each other, and in gases, what happens? The molecules are further apart from each other. So in the solids, yes, in the solids, all the molecules are compactly packed, very close to each other. So now look at what happens. If I disturb this molecule, if I create some sound here, if I create some vibration here, some disturbance here, this molecule is going to quickly transfer this disturbance to the next molecule because they are very close to each other. And this molecule, the second molecule, is going to disturb the third molecule. The third molecule is going to disturb the fourth molecule. And within no time, in all the directions, this disturbance is going to travel. It is something like this. If all 40 of you stand in a queue, very very close to each other, I push the first student, what is going to happen? All the 40 will get disturbed because you're all standing very close to each other, isn't it? But in the liquid, if I disturb this molecule, it will take some time to disturb the second molecule. The second molecule, because it is a little far from the third molecule, will take little time to disturb the third molecule. So from the first molecule to the last molecule, it will take some more time to disturb, for the disturbance to reach the last molecule. Look what happens in gases. If you disturb the first molecule, it is going to take its own sweet time to disturb the second molecule. Second molecule is going to take its own time to disturb the third molecule. So here, if there is some vibration in the first molecule, in the gas medium, it is going to take a long time for the vibration to reach the other molecules, isn't it? So in which medium is the speed of the sound fastest? Solid. Solid, exactly. So the speed of the sound is fastest in solids, it is slightly slow in liquids, and it is the slowest in gases. Fine. So I think we should wind up here in today's class. If you have any doubts, you can ask me. You can now unmute yourself and put up your questions about sound if you have any.